Hello students, welcome to Examora, your smart way to prepare for the exams. Welcome to today's session. I hope everyone has completed yesterday's homework and practiced it well. So today, we will explore some interesting number patterns and will learn how to find the missing numbers and discover the mathematical rules behind these patterns. So let's begin with question number 1. Look at the first pattern. 1 equals 1 into 1. So here, 1 is the first square number, right? 1 is the first square number. Now the next one, 1 plus 3. So 1 plus 3 is the answer is 4, right? Answer is 4. 4 can also be written as, we can written 4 as 2 into 2. 2 into 2 is 4. Then the next one, 1 plus 3 plus 5. 1 plus 3 plus 5 is 9. So 9 is also be written as 3 into 3. Then 1 plus 3 plus 5 plus 7. And the total, the sum of all these numbers are 16. So we can write 16 as 4 into 4. Similarly, 1 plus 3 plus 5 plus 7 plus 9. The answer is 25. So 25 is 5 into 5. So square number 5 into 5, 25. So the next pattern, it's after 9 plus 11. Next odd number is 11. So the total, the sum of these total is 36. 36. 36 is 6 into 6 is 36. Clear? It is very easy. So from this pattern, we can conclude that the sum of the first consecutive odd number is always a square number. So if we add n odd numbers, we get n square. So we can add n odd number, we get n square. Okay, this is the rule. So we can conclude that the sum of the first consecutive odd numbers is always a square number. This is the answer for this question. Okay, what is that rule connecting the number of odd terms added to the sum obtained? So n equal to, we get, if we add n odd numbers, we get n square. Okay, clear? So let's observe another pattern. Observe this pattern. See, the numbers increase and then decrease. Here 1 equals 1. 1 plus 2 plus 1. That is 1 plus 2 plus 1. 4. Then 1 plus 2 plus 3. First increase, then decrease. 2 plus 1. That is, here we can find out using an easy trick. Here the middle number is 2, right? So 2 square, that is 4. Here the middle number, the greater number is 3. So we can take the square of that number, that is 3 square, that is 6, 9. By counting all these sums, we all get this number 9. This is an easy trick. Just write the square of this number. So here 2 square 4. The middle number, the biggest middle number, the 3 is 9. Next one, 1 plus 2 plus 3 plus 4. 4 is the greater number. So, by doing the 4 square, we get the answer 16. If you have any doubt, just sum all these numbers, we get the same answer, 16. So the next number is 5. With greater number 5, we can there take the square, that is 25. Next one, 6, that is 36. So, see, here the answer we get 1, 4, 9, 60, 25 and 36. These all are square numbers. Therefore, all these are square numbers. what type of number sequence do we get adding counting numbers up then down? So we get the numbers adding counting numbers adding up then down, we get square numbers. Therefore, we can conclude that when counting numbers are added in increasing order, then the decreasing order, the sum is always a square number. We can conclude. So, when counting numbers are added in increasing order and then decreasing, the sum is always a square number. Okay, sum is always a square number. Okay, clear? So next one, hexagonal numbers. The numbers 1, 7, 19, 37 are called hexagonal numbers. So here, see, these numbers are called hexagonal numbers. What is the difference between consecutive terms? 7 minus 1, 19 minus 7, 37 minus 19. So first we can find out the differences. Number 1, 7 minus 1. 7 minus 1 is 6. 90 minus 7. 19 minus 7, 12. Next, 37 minus 19. 37 minus 19 is 18. So, see, here the differences are 6, 12 and 18. Notice that these each difference is increased by 6 here. All these differences are increased by the number 6, right? So the next difference will be 24. Because 18 plus 6 is 24. So the next difference will be 24. So the next question, predict the next hexagonal number based on these differences. So we can predict the next hexagonal number. So we can add 24 to the last number. The last number is what? 37. We can add 24 to the last number. So 37 plus 24. 37 plus 24 is 61. 61. So the next hexagonal number is 61. Clear? So next your practice time. Do all these questions. If there is any doubt, let me know in comments, okay? Let's move to the next set of questions. Write the number of sides and number of corners in hexagon, heptagon, octagon, nonagon and decagon, okay? So 6 shaped figures, 7, 8, 9, 10 shaped figures. These are called polygons. A polygon is a closed shape made up of straight lines. So, the first one, the figure. How many sides the figure? These are 6-sided figure, right? So, 6-sided figure, it is hexagon. So, first one we have to write here the number of sides, and then in the second line we can write the corners. So, remind that a polygon always has the same number of sides and corners. That is the rule. So here we can write hexagon. 6 sides. So 6 corners. Next figure, heptagon. Heptagon has 7 sides, 7 corners. Next, it's very easy. 8 sides, 8 corners. Nonagon, 9 sides, 9 corners. Here, decagon, 10 sides, 10 corners. So, you have to remind that the newer rule, the number of sides is always equal to number of corners. So, by heart this, number of sides is equal to number of corners. Next question, count the number of lines join 2 corners. The number of corners for the following figures. So, we can find number of lines and number of corners. First, it is very easy to find number of corners. 1, 2, 3, 4, 5. So, number of corners, 5. Then we can find out the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this figure has 10 lines. Okay, clear? So move to next one. First we can find out the corners, it is easy. 1, 2, 3, 4, 5, 6. So the corners, 6. Number of lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the number of lines, 16. Clear? So the one thing you remember, count carefully without counting the same line twice. Okay? So next question you can do it to yourself. How many triangles are there in each shape of the following pattern? Which number sequence does it give? You can do this question by yourself, okay? Let's move to question number 4. To create a couch snowflake, you start with an equilateral triangle 3 sides. At each side, each step, every side is replaced by 4 smaller sides. So, the couch snowflake is a famous mathematical pattern called a fractal. In every step, each side is replaced by 4 smaller sides. Here's step 1, 3 sides. Step 2, 3 into 4, that is 12 sides. Step 3, 12 into 4, that is 48 sides. So calculate the number of sides in step 4. So we know we can multiply the number by sides by 4. So 48 into 4. 48 into 4, that is 192. Okay, this is the answer. This is very easy. Notice the pattern. Each step has 4 times as many sides as previous step. Okay, clear? Assertion, reason, questions. Assertion. The sum of first and odd numbers is always a perfect square. Reason. 1 plus 3 equals 4 and 1 plus 3 plus 5 equals none. Is that statement true? Yes, the assertion is true. You know, 1 equal to 1 square. 1 plus 3 equal to 4. That is 2 square. Next order number 1 plus 3 plus 5. That is 9 is 3 square. So the first assertion is correct. Reason 1 plus 3 equals 4. The reason we already explained here is the reason is also true. Or these two assertion and the reasons are correct and the explanation also correct. So these examples prove that adding consecutive order numbers gives perfect squares. So the reason is also true. Assertion, so that we can say assertion and reason is true. And the reason is a correct explanation of assertion. Okay? Next one. Assertion, thus weakens 1, 3, 6, 10. Represent square numbers. Reason the triangular numbers are formed by arranging dots in a triangle. So, first assertion, see, 1, 3, 6, 10 are square numbers. No, it's not a square number. Square numbers have 1, 4, 9, 16, 25. These are square numbers. This is not a square number. These numbers are triangular numbers. Yes, these are triangular numbers, so assertion is not correct. And then check the reason. Triangular numbers are formed by arranging dots in a triangle. Is the statement correct? Yes. Triangular numbers are formed by adding dots in a triangle. The statements are correct. So we can say assertion is false and reason is true. Assertion is false and reason is true. Okay? Clear? So, whenever you get an assertion reason question, don't choose the answer by looking at the option first. Follow these 3 steps. check if the assertion is true or false. Second, check if the reason is true or false. Third, if both are true, ask yourself, does the reason explains the assertion? Then choose the correct option. Okay. So that's all for today's class. Today we learned how to solve associative reason quotients, understood the difference between square numbers and triangular numbers, and explore a small factual pattern through the triangular activity. I hope today's concepts are clear. Please complete the worksheets. And if you have any doubts, feel free to ask them in comments. Thank you for watching, and we'll see you in the next class. Happy learning!